Okay, so the idea of implicit differentiation, we've really already been doing it. Um, for example, if we were to think about something like this, y equals x squared, and we wanted to know what's the derivative, what we were doing, we said, well, the derivative y prime equals the derivative of x squared, so that's 2x. Now, we were doing more than just that, or rather, we could think about doing this as implicit differentiation, where we took our equation, the same one as before, and we're going to take the derivative with respect to x on both sides. So when we do that, what we see is, on the right hand, or sorry, on the left hand side, the derivative with respect to x of y is just dy dx. And then the derivative with respect to x of something squared is 2 times that something times the derivative of the thing itself. And this is using the chain rule. But the derivative of x with respect to x is just 1. So we get dy dx equals 2x. So we weren't really doing this process before, though we were getting to the same answer. So now let's just kind of keep this idea that we're taking the derivative with respect to x of both sides. So whenever you're taking the derivative of a variable that isn't x, usually it's going to be y, you'll get dy dx. And anytime you're taking the derivative of a variable x, dx dx is just 1, so that'll go away. So let's look at another example of that. And let's now use an implicit equation. So if we have like 2y plus x equals x times y squared. And we're going to take the derivative um, with respect to x on both sides. So now we're going to take the derivative with respect to x of this whole thing, and then the derivative with respect to x to that. Okay, well, on the left-hand side, we don't need to worry about any product rule or quotient rule or any of that. We have 2y plus x. So if we take the derivative of 2y, that's just going to be 2 times dy dx plus sort of, distributing this derivative action plus the derivative of x. Well, we know that the derivative of x is just 1, but just for now, let's say like dx dx, which is going to be 1, because the rate of change of x, it always has a slope of 1. Now that equals, well, here we're going to have to use the product rule on the right-hand side. So the derivative of the first, um, and again, we know this is 1, but I'm just writing dx dx for right now, just to kind of get the idea that I'm taking the derivative of that term, times the second, plus the first times the derivative of the second. And then what I'm going to draw in here to kind of help see it is it's y squared. So it's the derivative with respect to x of something being squared. So the derivative of something being squared is 2 times that something. But then we have to take the derivative of the something, and the derivative of that something is dy dx. So let's simplify this and then solve for dy dx. So when we simplify this, we're going to get 2 times, and for dy dx, I'm just going to write it as y prime. It's shorter, plus 1 equals y squared, because this is just 1, plus 2x y prime. And then in all these problems, the last step is just to isolate the y primes, factor, and solve. So we get 2y prime minus 2xy times y prime equals y squared minus 1. And if we factor out a y prime, we're going to get 2 minus 2xy equals y squared minus 1. And then we can find that our derivative, y squared, or sorry, y prime equals y squared minus 1 all over 2 minus 2xy. So going back, here we had our implicit equation. On the left-hand side, we took the derivative of each term. The derivative of 2y was 2 dy dx. The derivative of 1x was just dx dx, which turned into 1. And then over here, we had to use the product rule because there were two things being multiplied together, x times y squared. So we took the derivative of the first, which was dx dx, times the second, y squared, plus the first function, x, times the derivative of the second. So we had y squared, so we got 2y times the derivative of the inside, which was dy dx. And just one more example, and if you think you get it, then by all means don't watch this example. So the last one, let's say sine of y equals, let's say xy squared. Okay, so just some random equation, implicit equation. So we take the derivative of both sides. So we get the derivative of the left side and the derivative of the right side. And then when we take the derivative of the left side, the derivative of sine of something is cosine of that something times the derivative of the something. Well, the something, derivative of y, is dy dx. And that's going to equal, well, we've got the derivative of something squared. So the derivative of something squared is 2 times that something times the derivative of the something. So the something is, we're going to need to use the product rule. We have x times y. So it's the derivative of the first, which is 1, times the second, plus the first x times the derivative of the second. Well, the derivative of y is dy dx. This ends up being not a nasty, but a little bit harder factoring problem. But now it's all algebra. Now the last step would be just to get these dy dx's alone. So just to kind of go through it, we have cosine of y times y prime equals 2xy squared plus 2x squared y prime. And I'm going to move this over and factor at the same time. So I'm going to get y prime times cos of y minus 2x squared equals 2x y squared. So y prime equals 2xy squared over cos of y minus 2x squared. Let's see if this makes everything more clear for you. I hope